Hey guys, welcome back to math class. Well, sort of. Okay, welcome back. Hopefully you took advantage of that little break that we had there. This week we're going to move into the next chapter, more than likely the final chapter for the school year, and that's going to be chapter 11 on three-dimensional geometry. All right, so what is three-dimensional geometry? Well, we're going to take a look at some examples and learn some terms that we need to be familiar with as well. All right, so let's start off with the basics. All right, so here we have a three-dimensional cube. All right, so I'm sure we've all seen one of these before and in different forms. So a couple of key parts that we're going to be talking about that you need to be familiar with. All right, the side of this three-dimensional figure, all right, is known as a face. All right, so in this case it has 6 faces. All right, 4 around the side and then 2 on top and bottom. All right, where the 2 faces meet, all right, the edge, that's called an edge, all right? And then where 3 of the faces all meet, all right, right there at this singular point, because we know that 3 planes can intersect in a single point, that is a vertex. So we've got a face, an edge, and a vertex, all right? Now I want to take a look at what defines a three-dimensional figure, all right, based on how it's formed and its shape. All right, this is a cube, but its technical term is a rectangular prism, okay? So a prism, all right, is defined as 2 parallel congruent faces, okay? So the top and bottom, they run parallel to each other, right? And they're congruent, they're the same size. All right, and that is connected by these side faces. Okay, so what we're looking at for a prism, all right, is 2 parallel congruent sides. They can be any shape. It doesn't have to be a square. It can be any polygon, and I'll take a look at some examples of different ones as well. All right, and then these side faces will always be parallelograms, okay? So for example, this is a rectangular prism, aka a cube, because all the sides are the same. All right, we can have what's called a triangular prism, all right, so where the 2 bases, all right, the faces on top and bottom that are congruent and parallel, those are our bases, all right? Those are both triangles. And once again, the sides are parallelograms. In this case, they're squares because it's an equilateral triangle. All right, so I've got 3 faces around the sides that are parallelograms, and then I've got 2 parallel congruent bases in the shape of a triangle. So that would be known as a triangular prism, okay? We could also have something that looks like this, all right? This is called a hexagonal prism because the bases on top and bottom are parallel and congruent, and they are hexagons, 6-sided polygons. All right, the sides is going to equal this number of, or the side face is going to equal this number of sides on the base. Since it's a 6-sided polygon, there's going to be 6 faces on the sides. Okay, you can also consider these what's called lateral faces. All right, once again, those will all be parallelograms, okay, all the way around. Okay, so those are some examples of some prisms, all right. Now, we can also look at one to where that the bases are circles, like this, all right. So this would be technically called a circular prism because the bases are parallel and congruent. Those are circles. All right. However, this is known, and I'm sure you already figured out, as a cylinder. All right. So a cylinder is formed by 2 parallel congruent circular bases and a curved surface that connects the bases. Now, this isn't a parallelogram, but if we were to cut this down the side and open it up and unroll this curved surface around there and make it flat, it would actually roll out to be in the shape of a rectangle. All right, so it kind of is, but it's actually wrapped around the side there. All right, so those are examples of different types of prisms and the difference between prisms and a cylinder. Okay, so the next two shapes we're going to take a look at are pyramids and cones. All right, so I'm sure we know what those look like. Let's talk about the different defining parts of a pyramid. All right, so a pyramid is defined by a polygon base, all right, and it has triangular faces around the sides that all meet at a single point called the vertex. All right, so that's the vertex where all the faces come up to meet. If it's a pyramid, then all the sides are not parallelograms. There will always be triangles. All right, and then the base can be pretty much any polygon. In this case, it's a square. All right, so we could call it a square pyramid or a rectangular pyramid. All right, because the base is a four-sided figure. And then as you can see, we've got four triangles all coming to a single point at the vertex. Okay, so that's the base, that's the vertex, these are the lateral faces. All right, we could also take a look at a triangular pyramid. Again, the base is in the shape of a triangle, all right, but the lateral faces are also in the shape of a triangle and they all come to a single point. So this would be an example of a triangular pyramid. Okay. And then of course the cone is similar to a pyramid, all right, except for the base is a circular, so it's got a circular base, and the face is a curved surface that connects at the top, at the vertex. All right, so the really main difference is that it's got one continuous curved surface around the side, and the base is circular as opposed to being a polygon. So that's what defines a cone.